Hello everyone, welcome to Interview Prep Lab. Today we are going to see how we can design a scalable and accurate a distributed view counter for video streaming sharing platform like YouTube, TikTok, Twitch. This is a very interesting question, and the similar questions are like asked increasingly these days in the interview, and many candidates struggle to design a solution here. A similar question could be something like, how would you design a like counter in Instagram or Facebook? Or how would you design a retweet counter? They all have a very similar solution, and we are going to see how we can like fix this today. Okay. All right. So this is the prompt, and you are given this in the interview. And as usual, we can get started. So we will first like clarify any questions we may have, and we'll write those under our functional or product requirements. Okay. Okay. So here it's pretty clear. So you can write it down in points. So we can use this to design our system. Okay. So what do we say? Users can view videos, even though we can assume that this is already done. Okay. But this is a very important part of it. And when viewed, the view needs to be updated for the video, and content creators can query the latest video count. Once you've broken these down into simple points, you can just check with your interviewer, see if they want anything else. And sometimes they might say it's good, or sometimes they might say, like, hey, let's do, this is good, but let's do unique video count as a follow up. So, we can say follow up, or if time permits, uniqueness. So we can just like write this down. Okay. So once your interviewer is like on board, then we can like talk about non-functional or engineering requirements. And we will ask first question, what would be the scale of the system? And they might say billions of videos, and hundreds of millions of users, and videos can normally get several hundred million views. It's not the average, but it's possible. So we just like have to design our system so it can scale like this, right? The second one you can ask is like, okay, so what would be the latency that we are looking for? And in this case, the latency is like a very interesting one, because we mainly want to optimize for the content creators when they query the latest video count. So you can ask, and because this is a very big system, you can just say, hey, I'm going to optimize my system such that the query count is accurate within few minutes, right? So you can just say 5 minutes for content creators. That is the only one we have to optimize for. This can also be loosely translated to eventual consistency. That's it. You can ask any further questions. Availability is not a really problem here, so do not really bring it up. And that might tell interviewers that you were just like trying to go over all the points that you prepared. So ask only the relevant questions. Probably one relevant question that you can ask here is, hey, what would be the fault tolerance or durability policy here? And they might say something like, don't lose any views. So yeah, it's pretty much similar. You can, you might, like I said, you might get similar questions very adjacent, like build a like counter, retweet counter, um, advertisements, click counter, everything is pretty similar. So once you know the basics, you can pretty much transfer the knowledge and build any similar systems. Okay, so now this is done. We'll directly get to the next part. Usually, the next part would be like where you just like define any basic uh, entities for your system, the foundations for your system. In this case, there's really not many entities you have to think about. So you'll just like say, hey, I am going to assume that we just like need one video metadata entity. That's all you need. And this will have things like video ID, description of the video, creator, everything. You need only one thing, and that would be video view count. This is the only thing you need, and your job is to build a system that just like keeps this field updated. That's it. You don't really have to build anything else. Okay, so once this is done, there is we can directly get to the system. And if you want to like write an API design, all you have to do is like write only one API, and that would be something like post view, and the body could be something like video ID. That's all. Your client would emit something like this, and system would just say 200 or something. That's all. Okay, cool. Now let's get to the system. Before we get to the system, I'm just going to like start a very high level design, and then we'll directly discuss why that is not going to work, and then we can get to the like right system design. So you have a client, and this okay, so you have a client, and this client can be anyone, right? So let's just say it could be iOS app, Android app, or even like web app. So it doesn't really matter here. So whatever our devices, we will just like we just treat it as client. Give me 1 second, I'm just gonna clean this up a little bit. Okay, and your client as usual talks to gateway. This will take care of everything for me, like from authentication, from routing, from rate limiting. So it takes care of everything. I'm not gonna go super detailed into this one, and your interviewer doesn't usually like expect you to go over this. This is like pretty basic. So the next thing is like I am going to introduce my main service here, and that would be something called video counter service. All right. So my video counter service, at the very basic initial design, you can just like say something like this. Okay, my client, after watching a video, say for 1 minute, or like after spending 10% of time or something, you can define a logic here. That's totally okay. So this client emits an event, this like this one, like slash view and video ID, and after watching say 1 minute mark. So this is a very basic an idea. You can actually say that hey, you will optimize it based on the video length. For shorts, you can say something like as soon as the user lands and spends maybe like 2 seconds, you emit a video view count. Or if it's a long video, say a movie, then you can like probably emit a video view video event, say after 3 minutes. It's totally fine. We can like add more logic there, and we don't have to like focus too much here. All you have to say is your client will emit this event, and the very basic service, the API gateway receives it, then forwards it to video view counter service, and video view counter service just like goes to DB, and this is the video metadata DB. So and that's it. It just like updates the view. So this is a very basic system, and it would work for our basic stuff, and when the user can like directly query from the creator can directly query from the DB. This would meet our functional requirements, but when it comes to non-functional, looking at the scale, this is not going to work, and we know that. So your interviewer is expecting you to say this particular term, and that would be what we call stream processing. So this is what your interviewer is expecting you to say. So for any real time event gathering and event processing, this is what you will have to do. So we will write to a stream, and then there will be a processor that processes all of these events and then updates. So now let's redesign our system so it can actually scale, right? So I'm going to move this a little bit, and we will see how this system can be scaled. Okay, so right, so the basic would be the same. I have a client and I have a gateway, and then I have a video counter service. And but now instead of directly writing to the DB, what I am going to do is I am going to add some new components here. So my video counter service would write to a stream. So here, you just like have to mention that this is a stream. Okay, so it just like writes the event to the stream directly. That is the only thing that it does. So maybe you can add something like, okay, so here it does some validation and writes to stream. That is the only thing it does. And it will emit something like user colon video ID, and that way the stream has the information like directly written. Okay, very good. Now here for this one, you can just like also, if you want, you can mention a solution, and that's totally fine. You hear one of the popular ones is you can say uh, Amazon Kinesis, Kafka streams, anything is fine. Okay, so you can it could be anything. So you have now a service that's directly writing to the stream, and next you need a service that actually you need a service that processes this from the streams. So let's add a service here. Let's call it stream process service. So this consumes from the stream, and so here it could be something like Kafka or Kinesis. And for stream process service, every system, whatever system you pick, and they might have like a equivalent that like, hey, for this particular service, this is what we do. And so, but most of the popular ones, you can just like simply say, hey, I'm going to like go with a Flink. Flink is a very popular service, stream processing service. So that's widely used by many companies, including uh, the YouTube and TikTok, even Netflix uses Flink. So just like mention that. Okay, so what does this Flink do? So it reads from the stream, and it just like updates the view per video. So here the streams could be something like this, right? So it would say something like video 1 uh, user 10, video 2 user 5, again video 1 user 3, video 1 user 7, something like this. And it can also like have some timestamps here. So we can write something to the stream. If we want user information, we can write it. If not, just like video and timestamp, it's completely fine. So the stream will have all of this information. The stream processing service, when it just like consumes as it comes, it can also do batches, or it can just like do a real-time service. And what it would do is it would maintain a map of all the videos and the counts in that particular window. So it would maintain a video map which would say something like video 1, and in this case 3 is the count, and video 2 count 1. So it would maintain the map, and it would just like keep it for that particular window. And for Flink, usually it uses something like RocksDB. It's a very standard combo, Flink and RocksDB. You can, but that really doesn't matter. You can actually use any particular these days. Like you can kind of like mix and match, but it really it's fine. You can just like say Flink. Internally, it uses RocksDB to like maintain this counter, and for every few minutes, this is configurable. You can just say for every 5 minutes or so, it would flush this. And when I say flush, what it does is it actually updates the video to the main video database. So here we'll have like a, this is the original DB that we added for video metadata. So this DB will have video metadata, mainly video view count. So this is what we want. So what it would do is for every few minutes, it would update the, it would find the video, and it would like whatever the video count, say the video count is like at this point, uh, you know, 100, then it would just like take the, this is for the video 1. So if it's view is 100, it would just like take the number here 3, and it would update it to 103. So that's how it's kind of like, you know, an update. And so this is a very standard pattern to have one database where the users read from, and you do processing in a completely different database and then write to the main database where it's like, you know, the users can read. So let's say this is the you know, this is the, this is a separate client. Let's call it like the, this is a, sorry, this one's, I'm going to call it like the video creator. This is the video creator, something like we can call it like a dashboard service. And this directly talks to this DB, and any client that wants to talk to this particular thing, they'll go through this gateway, and then, you know, then they will talk to this service, assuming this is only for the video creators. So the video creators, they would just like, you know, connect to this service, and then they'd say, hey, what are the latest views on my video, and then it would like directly from here. So this is good. Okay, so now let's just like go back and see. Let's see how this would scale for billions of videos. So you'll have like way too many videos and way too many users, millions of, hundreds of millions of users watching the videos, and they would be emitting the events here. And so we would be getting like several hundred millions of events um, every day, and sometimes you can be like having like tens of thousands of events every particular second. So what we do is like we would shard it based on the video ID, and then we would write it to the stream. And the stream processing service for every few, so like we said, like this is configurable, but you can say like start with, I'll start with like, you know, something like 3-minute window. So for every 3 minutes, it again, this is also based on the this is also sharded based on the video IDs. So for a particular set of video IDs, a stream process service would be like responsible. It would just like pick up, and it would like keep a counter locally, and then after a few minutes, it would directly flush to the DB. So the latency is good, we are covered. So this would like scale, and for, sorry, for scale, this is covered. For latency of 5 minutes, we like set it as 3 minutes, even 4-5 minutes, totally fine, and we'd be good. So now we have covered these two, and the next one would be don't lose any views. Our system, if we just like go, let's see if we can lose anything, right? So an event can come here, and once it reaches, we directly write it to the stream, right? So we write it to the stream, and then after that we acknowledge. If we don't acknowledge, the client would resend it, and so it's fine. So we will not lose any views, right? So the video counter service, we don't lose any views, and then we write all of it to stream, and then the stream processing service consumes it, and in general, like, it would keep a count for every, like we said, like for a few minutes it would count it in the keep the count in the local db, and then after that it would flush. If for some reason this fails, or this particular process fails, it would have an offset committed from the stream, so it would just reread, and that's totally fine. So we are like setting a window of 5 minutes. So worst case, it will reread all the 5 minutes of events, and upon crash, and it would write to the db. So this is totally fine. However, there are always things that can go wrong here. We might lose a view or two here and there due to various reasons. It could be as simple as, like, a timestamp mismatch, or a network problem, or even like a small uh, bug in the code. Like, one of the stream processing service got like a latest update, and there is a bug. So we cannot always like say for sure that we will not lose any views. And in cases of views, like for example, say a particular video has like 100 million views, and if it loses a view, I think that's okay. But imagine we are designing something like a advertisement view aggregator or click aggregator, right? Every click can mean dollars, and we don't want to lose it. So we have to have a reconciliation path, and we can like design it here, and we can pretty much like extend the same design to any other system. So how would we go about it? So we have a stream, and what we can do is we can add a separate service that actually, that's what we call the reconciliation path. So let's start how it would go. So we have a stream being written here, right? So let's add a separate raw event source of truth, not source of truth, like raw event collector. So we can say that, okay, I'm going to add something like, s3 here, uh, and it would just directly, you have a service that just like directly, whenever the events are written to the stream, they are also added to s3. So we have a list of all of the events emitted, added to s3. This would be a backup in case things go wrong. And again, like, this can be partitioned based on the video id, so that's totally fine. And now I will have another processing engine. So I'm going to add a separate processing engine here. So we can call it like any batch processing would be fine. And this batch processing, what it would do is it would just read from this S3 on a particular window, and it would have a count of its own. So this is a batch processing service. And this batch processing service, you can, for this is like Flink, so we can just like go with the Flink family. So Flink has this thing called Flink batch, and this Flink batch would read from S3 on a particular window. And so this could be something like, configured to say 12-hour window or something. So 12-hour batch. So this particular service would run every 12 hours, and what it would do is it would read all of the events emitted, and it would maintain a count on its own. Again, like, it could use, if we use Flink, it would use like RocksDB, and it would maintain a count of all the videos and views in that 12 hours, and then it would then go to the DB and directly update the count. So what this what this means is we have to make some small changes to the video metadata. So I would add something very simple here. So video view count, we can add something like last reconciled at and last reconciled count. So how would it work? So for a video, let's say video 1 to 3, right? It would say something like the current video count could be something like 15,000. Okay, this is the video count, and last reconciled. Sorry, I'm going to copy this. Last reconciled at could be something like 12,000. So, and last reconciled count would be, say, 14,000, which means in the last 12 hours it's got additional 1,000 views, right? So this batch processing, so this latest number is coming from the stream processing service, right? So here what we do is it would batch process all of the views at 12 in the last 12 hours since this particular timestamp, and then it keeps a count. It keeps a count of all the views in the last 12 hours, then comes back here, and then it would just like the last reconcile count. So now say it has something like 1005, and here the video count would be updated to 15,005. So it would update it rather than directly updating this would update this. And so if our system is working just fine, then it would be 15,000 because like we have not like lost any particular views. But it's possible that like I mentioned, there are like various things that can go wrong, and if things go wrong, then we would have like a discrepancy between these count, and it would just like have here. So this way, now we have a list of all the views. So this one we can assume that pretty much like we did not lose anything here, and we just have to add this here, and you can have like a additional service that would just like check if there is a discrepancy. You can have like a separate observability system here that would just like emit information to the producers, to the company. Hey, this is the average, the difference between the direct update and the reconcile update, and they can finally figure out like where things go wrong. For a very small count, they would use this as a way to fix things. You can simply patch it, if it's like 5 additional views, it's not a problem. So you can have a separate job to patch this to 15,005 at this particular timestamp. But if the number is like pretty drastic, say 16,000 or so, or some significant percentage, then you can have a separate process that actually handles these things. But that's out of the scope of the video, but usually this is good. So we have everything that we covered, except we can add like uniqueness. Uniqueness is many people definitely would like to follow up on, like how would you ensure uniqueness here. uh, the uniqueness count can be done at the part of the validation. So this is what I would usually go about. This is how I'd go about it. So you can have a separate DB here. So in this DB, you will have a format of video ID and viewer ID. So this would maintain a video ID and viewer ID combo for all of the users. So if a particular user, say user 5, watches a video then it would have a record here for the very first time. And if the same user watches the same video after, say, a few days or like after 1 hour or so, then the video counter service would first, before writing it to the stream, it would query the DB to see if, so this is how it would query. Uh, the video ID, let's assume that the video ID is like 123 and the user ID is like, user A, BC. It would see if that particular record exists. If it doesn't exist, then it would write to the stream. If it exists, then it will not write to the stream. So this, you can use this. You can also add a cache layer here to keep the count for recently processed views. And I've seen some people struggle with this. It's a very simple one, but many people would say, hey, I would just like have a something like video ID and viewer ID like in a separate table, like a video view, and it would just be like, hey, select star from video viewer count where video ID equals this and viewer ID equals this. That's a very big query. You don't really need to do that. You can simply like just do this and index it. So that way it's like a one quick lookup, and that should work for you. Okay. Okay. Think we are done then. Thank you so much for watching this. And if you have any questions, feel free to comment. And if you like it, please share it with your friends. Thank you.